I've been reading a lot about the MRE device, which is a magnetic resonance amplifier invented by Joel McLean and Norman Wooten. And I got inspired to build something similar. It's not quite an MRA device, but I've been inspired to use a magnet again, which is this time is a magnet with a primary and a secondary. And I'm getting some great efficiencies, and that's why I wanted to share with you my experiment. So for the current draw, we are using 48 milliamp at 8.06 volt. And this is a 5-watt light bulb, 220 volt UK mains. I'll show you the setup. So I've got a magnet with a primary and a secondary. The green wire is the primary. I've wound 100 turns of green wire, which is the primary. Then I've cut the wire, and then in between I've used my secondary coil, which is the gold coil, and then the back on the primary on top. So I've added the primary on top. So I've got two green wires, which is the primary, and the end of the first wire connected to the start of the second wire is then twisted and connected to the positive of this circuit. So that's the center tap connected of the primary to the green circuit, and then the other two wires are connected to the push-pull of the circuit. So this circuit here is called a DC to AC converter, using the chip called the TL494 chip, which is frequently used for push-pull circuits. And I've noticed that the efficiencies is really coming from this transformer. I initially had built just a conventional transformer with 2 E-cores, and it took me most part of the day to wind this neatly. When I connected this transformer to the circuit, the current draw from this was 500 milliamps. It seems that the current just sink into the core and there's no efficiencies at all. So I was inspired again by the MRA device, and this is a sort of similar sort of idea where we've got a magnet and we've got a primary and a secondary wound around the magnet, and the efficiencies on this light bulb are 46 milliamp for the current input, and then the voltage is 8.06 volt. And this is really pretty much the setup. I'll show you a shot of the oscilloscope just to give you an idea. So we've got the frequency here is the signal is ringing a lot. There's lots of ringing in there, and we've got a minus voltage of minus 16 volts, a min voltage of minus 15 volts, and max voltage of 22 volts. So we can see that we've got a negative cycle and a positive cycle. And we've got a slightly higher positive cycle. And the volt peak to peak is 38 volts on the underload. Usually dual fifth can get the light bulb to turn on around 65 milliamp, but it's extremely dim. Here in this situation, it could almost be useful as a actually night lamp. It's really efficient and just the best efficiencies I've had so far. I'm hoping this will inspire people to do some more research. If you're interested in reading more about the MRA device, have a look on Rex Research. There's lots of information, pages and pages about the magnetic resonance amplifier. Lots of really interesting information about the MRA device. And this is all for today. Thanks for watching.